Okay, so when solving circular functions for their exact values, we're often given a domain. So for this question, we're going to treat theta as belonging between 0 and 2 pi. So the first thing we want to do is transpose the formula, so we just get sine theta by itself. So let's divide both sides by 2, which will give us sine theta equals root 3 on 2. Now the first question you ask yourself is, what first quadrant angle would give us sine that equals to root 3 on 2? Which would be pi on 3. Alright, so that's our first quadrant answer. Now if we're going between 0 and 2 pi, we know that we've got pi on 3 in the first quadrant will give us positive root 3 on 2, and we also know that sine is positive in the second quadrant, so we need the angle that is pi on 3 away from pi. So our second solution for theta would be pi minus pi on 3, which would be the first answer would be pi on 3, and so then we'd get 2 pi on 3 as our second answer. When solving more complex equations where we've got a coefficient in front of the angle, so in this example sine 3 theta equals negative 1 on root 2, we know that theta belongs between 0 and 2 pi, so we can say, well, 3 times theta means that we've got to multiply both the endpoints of this domain by 3, so now we're looking between 3 theta belonging between 0 and 6 pi. So we're going to have a few more answers this time. So we know sine of pi on 4 equals 1 on root 2, which is our first quadrant angle, and in the question we've got a negative 1 on root 2. So sine is negative in the third and fourth quadrants, so we want to go pi on 4 away from the x-axis in both the third and fourth quadrant. So our solutions for 3 theta would be, if we're going between 0 and 6 pi, our first one would be pi plus pi on 4. The next one would be 2 pi minus pi on 4 to get our fourth quadrant angle. And then we keep going around because 6 pi is 3 full rotations in a unit circle, so we'd go all the way around again, which gets us to 3 pi plus pi on 4, which as a shortcut you'll notice is just the first solution, pi plus pi on 4 plus another 2 pi. Our next solution would be 4 pi minus pi on 4, and then we go around again to 5 pi minus pi on 4, so 5 pi plus pi on 4, and then 6 pi minus pi on 4. Solving all these out would get 5 pi on 4, 2 pi minus pi on 4 would be 7 pi on 4, then would get 3 pi plus pi on 4 would be 13 pi on 4, 15 pi on 4, then 21 pi on 4, and 23 pi on 4, which remember is still 3 times theta. So the last step here is now to divide both sides of the equation by 3, so we've got to divide each of these fractions, 5 pi on 4, 7 pi on 4, 13 pi on 4, we're going to divide all of these by 3, which means that we're going to actually multiply the denominator by 3. So our final solutions would be 5 pi on 12, 7 pi on 12, 13 pi on 12, 15 pi on 12, and 21 pi on 12, and 23 pi on 12.